Alrighty guys, today I'm going to show you how you can fix the dryer if it keeps blowing out your thermal fuses and whatnot. It's the washer in the background, so you guys don't know what that sound is, but we are working on the Amana dryer. The quick disclaimer, depending on what make and model you work on, they all look kind of different. They all look kind of similar, so the model number that we're working on today is turn on the light so you can see. Here's the model number. Amana, which is made by Whirlpool. The model number that we're working on today is NED 4655 EW1. It's by Whirlpool Corporation. The serial number is MX2061800. The serial number may be different for what make and model you work on. It runs on 120 or 208 volts, 120 240 volts through a full wire connection. My dryer runs on 240 volts, and that's dangerous stuff for you to work on. So before you work on the inside of your dryer, you gotta make sure that you unplug the power, disconnect the power first before you mess around with it. It's because you do get electrocuted. 240 volts, it's not good to mess with, okay? Just make sure that you unplug the dryer before you get started. So let's go ahead and close the door. Mom was sleeping, so we have to carefully close it. And so the first thing that you need to check if your dryer just keeps blowing up fuses is the lint. Okay, you want to make sure that you clean this before and each load. That can cause airflow problems, and that causes your fuses to blow. Okay, all right. If that does not fix your problem, if your fuse just keeps blowing, chances are it's probably the next part that I should check is your venting system, which is inside of which is the back of your dryer. If it gets lint build up, the dryer vent can't breathe, and otherwise it will cause your fuses to pop. So that's another common issue when you work on these dryers. So other than that, so let's see. We check we confirmed the lint, and I haven't checked the exhaust vent. So now the next problem that I should consider is the fuses are bad, or a shorted heating element, which is right on the back of the dryer. So I'm going to show you how to get to it. You got to make sure you unplug it first. It's because most dryers runs on 220 volts to 240 volts of alternating current. So it's unplugged right now. So it should be safe. And also, not only that you unplug the dryer, you gotta make sure all the controls are off. It's because you don't want the dryer to turn on you while you work on it. That's another important safety thing before you work on it. Okay, so you got all the controls are set to off, got it unplugged. So now it's a matter of working on it. So the dryer is very heavy, so if you don't know what you're doing, or if you have any trouble moving around, just get somebody to help you. And help you pull it out. So my dryer is very easy to pull out. I mean, it's not that hard as I thought it would be. So I'm gonna go ahead and pull out the dryer. It's probably hard to do while you're filming at the same time, so I have to. It's unplugged right now. All right. See, I should be safe. Just make sure you be safe before you work on this now. Oops. I have to move this back just a little bit. Alright. Got the power cord laying down on the floor. I don't know, you should be doing that, but I think that there's a way that you can hang it into the, you know, but, you know, just move this back so you gain access to it. And right here, this is the vent. I checked the venting. So probably there's some lint right there, which you can see it. Doesn't look as bad as it thought it would be, so now the dryer, the back of your dryer has 1, 2, 3. Let me have a trouble. I need to learn how to talk right. The back of your dryer. All right. So here is the back of your dryer. So you have your control board. In this, we have your control board cover. We have your electrical cover, and right here we have your back of your dryer, which contains your heating element, your blower, and your fuses. So this and this, I mean the control board and your electrical wiring. You don't need to mess with that unless you know what you're doing, which I know. But what we're gonna be focused is which is the big back. So the back cover has 1, 2, 3, 4, 5, 6, 7. I think 7 screws. 7 bolts, or what you call it. So in order to take the back off, you have to undo these bolts. But also, a quick disclaimer, it's very sharp, and just be more careful so you don't cut yourself, okay? So, it's unplugged right now, so it should be safe. Alright? Always be safe before you work on this. Okay? This and this, you don't have to worry about messing around with it. It's because everything else is working just fine. You just have to focus on your fuses and your heating elements. So, now let's go ahead and take the back off. But before we do that, I'm not gonna vacuum out the duct. I mean, not the what do you call it? The exhaust. You know, it's because it's late and I don't want to wake anybody up. So with my screwdriver, I'm going to take all these screws that hold the back in place. But just make sure you confirm that you unplug it. It's because, once again, 240 volts. You can.
Are you working on the dryer?
I know. I'm just. Yeah.
It's hot up in here.
I know. I know. I'm just gonna. Sorry, that's the.
75. Right.
Yeah, I'm just wanted to make a video on YouTube of the yeah, I'm just wanted to I'm just wanted to I'm just wanted to show the YouTubers how you can fix the dryer if it keeps blowing up fuses. Alright, so we're gonna take all the screws out. The good hint that I know from my dad, you always need to start with the bottom screws first and then just work your way to the top. The reason why is you don't want the cover to hit at the floor. Alright, so I'm gonna go ahead with my electric screwdriver with nothing attached. We're gonna unscrew these screws. Alright, just make sure you don't lose them, okay? It's because once you complete with your repair, when you put your dryer all put back together, you know where the screws goes in, alright? So move this a little bit further just to get into that screw right here. There we go. We'll do this carefully so we don't wake anybody up. Alright. So we got that screw. Now I'm going to take this screw off. A little hard to get to it, but alright, that screw is off, and it's late right now, so just want to do this more carefully so you don't wake anybody up, cause the noise complaints. Alright, now that's screwed. Rest of the screws. Alright. Make sure that you keep track of all the screws, and that is because when you work on these things, you want to make sure that you keep track of everything. I put the screws right there just to make sure. It's magnetic, so you don't have to worry about losing your screws while you work on it. So, all right, you can see the cover shifted the holes a little bit, and then there's one last screw, final screw. All right, and then, once you take the screws out, now this cover should come right out. Just be more careful because the edges and corners are very sharp and it can cut yourself, okay? Just make sure you be careful when you take this off, okay? Just take your time, no hurry, just make sure that we unplug it before you work on it. Because once again, 240 volts, don't want to mess with it while the power is energized. Alright, now go ahead and put the back cover aside. I think we should put it right there. Alright, so now you got the inside of your dryer. So now I'm going to show you what every part is and show you how you can test for continuity in case if your part is bad or shorted out, then you know which part is not working and it needs to be replaced. Alright, so first right here, this is your heating element. The heating element's job is to heat the inside of your dryer up to 95 up to 195. It just depends on what you have your heat setting at. It's because some dryers will have your temperature select, so you can set how hot you want to get. Like no heat for like real delicate, so the heating element always stays off, and then low heat which will turn on the heating element for a short time. Because this is the thermostat right here. I think that's just a thermostat, or I think that's the thermostat. Alright, 80 degrees up to 250. Okay? So, when you have it on your temperature control set high, the heating element will stay on for longer until once it gets up to around 250 degrees or less, depending on what make and model you work on. Oh yeah, that's the cycling thermostat right there. Yeah, I think that's the cycling thermostat, which is right here. That's the cycling thermostat, and that's the high limit thermostat. Okay? So, once it gets up to 155 degrees, the thermostat will open, and that shuts off the heating element. And just to help protect your fuses from blowing out in case if your dryer ever gets too hot. Okay? Alright, so that's the heating element. Right here we have your, I think this is your high limit thermostat right here. The high limit thermostat actually does is when you in the event if your cycling thermostat won't do its job, the high limit thermostat right here will open, and that shuts off the and that also shuts off the heating element, so you don't burn out the heating element and cause damage to your dryer, and bad things can happen from it. Okay, so this is your high limit thermostat right here. And this right here, this is right below this I think this is above the cycling thermostat. This is your thermal cutoff fuse. Any event if your dryer ever gets too high, like if it's overheating, the thermal fuse will pop, and that shuts off the dryer to prevent damage to your dryer and the components. It's there for safety measures, so you don't cause a fire hazard and cause it to explode, and bad things can happen from it. So that thermal fuse job is to protect your dryer in case if something happens, like if it gets so hot, like if the heating elements was staying on for a long time, it can cause your thermal fuse to pop, and your dryer won't start and run and heat until you replace this part, which I'm gonna show you how you can test it at the later in the video. Okay, so let's see. And right here, this is your blower fan. The blower fan, this job is to keep the air circulation from inside of the dryer. All right, when it gets just to keep all the cool down, all the I think I got mixed up sometimes. The blower right here that's your blower shroud, and the blower is right behind it. Okay, the blower's job is to keep their air recirculating while the dryer's in operation. All right, and that blower turns on along with the motor, which is right behind this, which I don't know y'all can if you can't see it or not, but I'm not gonna get into how you can check the motor. But in case if your dryer ever stops tumbling or something like that, chances are it is probably the motor have fault. Okay, so, alright, up to click on the thermostat. So, if you guys don't know what that noise is, it's the click on the thermostat. The thermostat has been satisfied, so it shuts off the HVAC system. So the blower right here, like I just mentioned, the job is to recirculate the air, and it keeps the dryer working. Okay, and this fan also controls the exhaust vent too, and that's what all the hot air pushes out. That fan is very powerful. Alright, and that fan job is to, like I just mentioned, it keeps the air from recirculating, and not only that, the fan also helps catches lint. So in case if your fabric and your clothes gets lint, it captures into the lint screen, which is right behind inside the fan shroud. Okay, and that's what all the lint gets caught and captures by the lint screen. Okay, and that's why they should clean it before and after each loads and between loads, so you got good air recirculation. That's the thermostat again on my HVAC system. Just click back off. So, alright, the airflow is the most important factor. It's because without that airflow, the dryer will get hot quickly and causes your fuses to pump, and bad things can happen from it. Alright? And I'm not going to go in complete detail on how to how to gain access to your blower. I did it one time just to help clean up the lint and such. Look, there's lint right there. Look. Look at all that lint. Then right here, if you can't see it, that's the dry motor. Alright? Pretty cool, huh? Alright? So, and also the fan blows the air on the lint. I mean, not the air on the lint, the exhaust. So the fan blows both the exhaust and the inside of your dryer, which catches all the lint. Alright? So, alright. So now we know that part is. And then right here you got all the rest of your wiring that goes along with your power cord, and it goes into your control board. Okay, so I'm not gonna go in complete detail. I'm just wanting to show you how you can fix in general, because sometimes chances are if it stops working, like it's not heating, chances are could be the fuse. So this right here is your thermal fuse. So the thermal fuse job is to, just like in your thermal cutoff fuse, in the event if your dryer overheats or if the heating element is working too much, it will pop that fuse and causes the dryer to get probably the dryer will work or probably not work if I'm too certain, but it's not heating. So this thermostat, this thermal cutoff fuse's job is to help protect all of your electronics inside of your dryer, just like in your thermal cutoff fuse, which is right there. This is your thermal fuse, and this is your thermal cutoff fuse. Alright, so now this is your power cord, and right behind it, it's all of your wiring and such. Not going to go in complete detail. I mean, the dryer works. It does turn on. It does turn on as long as your thermal fuse is good. It's not the wiring issue. And then right here we have your control board. This is how you get into your push to start button right here, and your timer. And then depending on what dryer you're working on, you may get more knobs, like one of them for the heat setting and one of them for the the extra functions like your cycle signal, your winkle prevent, which mine does not have extra knobs, just your timer knob and you push the start button. So, alright, well, I think that's pretty much all it. So, let's see, what else? What else did I show you? Oh, the drive motor, which is right there. If you can see it, that's the drive motor. Okay? The motor's, and you can see the motor right here and the belt. The motor's job is to drive, to spin the drum and the blower at the same time. Alright, and that motor's job is to tumble to close. Look, that's the drive motor right here. And this motor has a, what do you call it, like a typical switch. So in case once the drive motor gets up to speed, those two things will spring forward, what keeps the speed stable. And not only that, it helps prevent your drive motor from burning out, which is a good thing. And that motor also has its built-in thermal protector in case if something happens to it, it will shut off to prevent damage to your motor. All right. So let's see. We got the motor. You can see the wiring, and we have your Eibner pulley that draws tension to the belt. And this wheel right here keeps the drum balanced. Pretty cool, huh? And then some dryers will actually had a belt switch. I'm going to show you what the belt, here's the belt for it right here. Now, the motor drives the Eibner pulley and it drops the belt that makes your dryer tumble and your blower at the same time. That goes along with the motor. Alright. Alright, so I think, let's see. Oh, some dryers will also have like a Eibner pulley switch or belt switch, so in case if your belt ever gets broken and worn out, it will shut off the motor. I mean, it will shut off the motor. The motor, and I think the motor and the heating element, so you don't cause any damage. Alright, which is right here. You can't see it, but you know, depending on what dryer you work on, you may or you may not have that belt switch or pulley switch that prevents the motor from running until the belt has been replaced. Alright, so now let's alright, so now you know what's inside of the dryer, then all the parts and everything works. Now it's a matter of testing things. Okay? So we're gonna get out my multimeter. Okay? The meter is in my room. I'm going to show you how you can do some testing in case if your dryer ever stops working or it's not heating properly or not working properly. Let's see, let me get, where's my meter? I think I had it here somewhere. I'm going to pause the video until I look for my meter for a little bit. Is it back there? Let me see. Let's see. I think the meter is right there if I... Alright, I'm going to pause the video until I look for my meters. So, give me a moment, guys. Alright, guys. I found my meter. So... Alright, okay, so now, once you get your, once you get your meter out, go ahead and open that up, depending on what meter you worked on, you may or you may not have that little thing, or what I call it, that little protective sleeve. This is how you keep track of all of your stuff. So let me go ahead and open that up. Alright, sorry about that. And alright, that's the meter. Depending on what meter that you worked on, they all work kind of very similar. Gets a little complicated, but so the meter that we work on is this Astronomy Smart Auto Range. It has auto function. It also has an auto power off function. So in case if you're like if you accidentally leave your meter on and then if you forgot to turn it off, it turns off free to help save battery life, which is a good thing. Alright, so go ahead and take off these little protective things. Depending on what meter you work on, you may or you may not have that little cap, that little protective caps. Take this off. Alright. And there you go. Alright, so I'm going to go ahead and connect this common wire, which is right here. The black wire, this is your common wire. Alright. And the red wire, so your input wire. Alright. So we plug that in. Plug two of these in. Alright, so now once you got your meter all hooked up, go ahead and turn it on. Just hold the power button down. Like I said, depending on what meter you work on, you may have a different way to turn it on. Like most of the meters will have a like a little selector knob, which this meter does not. So to turn it on, you just hold the power button down for I think it's around 5 seconds. Oh, 2 seconds, my bad. Alright, so auto. Alright, so now let's go ahead and test out the heating element first. So to do that, go ahead and put the common reader right to the ground, and come over here and take out the red positive, you know, input for your positive, common for your negative, and go ahead and test out all the heating up, let's go ahead and test out the short heating element first, because chances are, if your heating element is the source of the problem, you might have to replace it or repair it, and then replace it if it's not repairable. I don't think that the heating elements are repairable, but so let me go ahead and get so before we get started, you want to make sure that you calibrate the meter to make sure it reads 0. So go ahead and do that. Let me show you. I'm gonna put it's kind of hard to do it, so just get the touch one that probes together. There we go. And then listen for a beep. Oops. There you go. Alright. It's a little loud, but don't panic. It's just how it works. Alright, so now let's go ahead. Alright, so you want to make sure this reads 0 when you calibrate. So let me go ahead and show you that real quick. Gotta make sure it reads 0, otherwise it's not calibrated. So I'm going to go ahead and show you. Once you touch these two probes together, it should read 0. There you go. Alright, let me make sure. Perfect. Alright, so now let's go ahead and test. Alright, so once you calibrate the meter, now it's a matter of testing your stuff. So let's go ahead and test the heating element first. So do that, you have to touch the common wire to the ground, which is right there. And then, right here, look. And then go ahead and connect one of the probes in. Run the heating element terminal. So let me go ahead and do that. Oops. There we go. Let me go ahead and get my camera reset up. I can back up just a little bit. Hopefully y'all can see a little bit better. Alright, so we're going to touch this. Oh, the air just kicked on. That's the thermostat click. So we're going to touch this, and oh, there you go, and then touch this. Boom. We have a short heating element, guys. So let me go ahead and show you the meter again. Let me find a different angle. That way y'all can see the display a little bit better. So we got auto, and I don't know if y'all can see the display, but I'll show you which reader's meeting. Alright. It's about 3 to 2 ohms. Alright, so now let's go ahead and plug this back in, and then go ahead and unplug the high limit thermostat. I know the wires kind of loosen a little bit, but I'm just trying my best to tighten up because the plug is not tight enough, so I had to tighten up the plug. So alright, so the same thing. Move the camera around so you can see what I'm doing. So again, go ahead and touch these. The common wire goes in here, and go ahead and test. Oh, let me get the camera back in focus. There we go. And then hopefully y'all can see it or not, but let me go ahead and touch this. Boom. Shorted, grounded out heating element. Alright, so continue to test all the fuses. Go ahead and unplug this one. Alright, unplug this. Again, touch this. This is your ground. And go ahead and, oh, and we, hopefully y'all can see a little bit better. Oh, hang on. I know the camera is all messed up. I'm sorry, guys. Let me go ahead and put, alright. There we go. Y'all can see it a little bit better. Alright, go ahead and, alright. That way y'all can see a little bit better. So common wire, touch this. Oops, the wires are in my way. Apologize. So right here and right here, and see what we get. It's about like 4 to 5 ohms. So I think we got a culprit. Shorted out heating element. Alright. So now let's go ahead and go ahead and test the thermal fuse that goes along with the heating element. So I'm gonna go ahead and, I don't know if y'all can get it or not, but alright. So now we found the culprit, guys. Shorted out heating element that causes the heating element to stay on longer than thought it will be. Alright, so I have replaced the heating element at one time, and that worked just fine. So I think the heating element has shorted out again. It shouldn't happen that often, but that's stuff breaks sometimes. But alright, so now let's go ahead and check the I think that's the high limit thermostat. Alright, so we unplug the heating element and unplug this and make sure that the meter is on. and go ahead and touch these wires. Hopefully y'all can see it or not. Go ahead and touch these. Oops. There we go. Go ahead and do the same thing for... Oh, hang on. Let me reset my camera real quick. I had to get a I should get a tripod for myself. That way y'all can see it in more view. Alright. Let's see. There we go. I think y'all can see a little bit better. Alright, so let me go ahead and test the high limit thermostat. The meter should, when you test out the fuses and such, the reader should get 0 ohms. 0 ohms, that's the gold standard, okay? So let me go ahead, and then I don't know, but since the meter is right next to my phone, I'm gonna show you which reading you get. It should be get closer. The reader should read closer to 0 ohms. So 0 ohms. That's our gold standard. All right. Oops. Oops. Hang on. Let me get this. Two ohms. I mean 0 ohms. If I can show you that here. Oops. There we go. A little closer to 0 ohms, which is perfect. Perfect. Alright, good. And now go ahead and reverse the wires and test the other side. We should get the same reading. Oops. Perfect. Alright. It doesn't have to be complete 0, but you know. Alright, so now let's go ahead and test out the high limit thermostat. So to do that, let me go ahead and plug these wires back in. It's probably a good practice just to plug them back in. That way, so we know which plugs in goes in first. All right. I mean, which wire plugs in which. All right. So now let's test out the high limit thermostat, which is right here. So go ahead with the meter on. Go ahead and let me find a better spot. There we go. We can see a little bit better. Now go ahead and touch these. Y'all should get 0 ohms. It doesn't have to be complete 0, but oops, there we go. Perfect. 0 ohms. We want that, guys. Perfect. Alright. Now, go ahead. I'm going to put the display. That way y'all can see a little bit better. Oops. There we go. Perfect. Alright. So now you know that the high limit thermostat is working. So go ahead and plug these 2 wires in. Alright. Alright, so and also here's the thing. If your meter does not show anything, then you know that your part is bad and it needs to be repaired. If it's not repairable, replace it. Alright, let's see. So we got the shortage of the heating element. We confirmed that. We got our thermostats, high limit thermostat confirmed. Then we have continuity. And now let's go ahead and test out the the thermal fuse, okay? So go ahead and unplug these wires. Just wiggle around a little bit, alright? And do the same thing, alright? And go ahead with the meter. Touch these probes right here. Oh. Alright. Oops, let me find a better spot. I know, it's hard to do while you're filming, so go ahead and touch these two probes right here. Oops. Move this out of the way, that way y'all can see a little bit better. Alright, so I'll show you what the display is reading. Oh. I think we found the culprit, guys. We have a bad thermal fuse. Okay? So this fuse needs to come out and inspect and replace it. I mean, repair. If it's not repairable, then your fuse is bad. Alright, so now this fuse is bad, okay? We confirmed that. Oh, that's the meter. If you don't know why it's beeping like that, it's because the auto power off is about to turn itself off. So I'm gonna go ahead and turn it back off and disable it. I mean, you don't have to if you don't want to, but that can use more battery on the meter. So, alright, so we all know we got a shorted heating element, we have a bad thermal fuse. I think that's the thermal fuse if I'm unsure. Alright, so now let's go ahead and test out the cycling thermostat. Alright, so go ahead and unplug these two wires right here. Alright, and alright, with the alright, so let's go ahead and test these two heating the cycling thermostats out. You can go ahead and keep this one plugged in. It makes it better for the wires and such. So I'm gonna go ahead and touch these and get the camera position here. Oops, hang on here. I don't know, y'all. Yeah, we need to. I should get a tripod for myself, that way y'all can see a little bit better what I'm doing. So go ahead, let me get this back in focus, there we go. Oh. There we go, zoom out a little bit so we can see. Alright, so I don't know y'all can see the terminals and such, but this. Alright, now go ahead and move that. Just make sure you know which wire goes in which. So, alright, you got the meter on, go ahead and touch these two. Make sure we get a right reading. 0 ohms, perfect. Perfect. 0. That's good. Alright, so now we confirm that the cycling thermostat is working, but only on one side, okay? I think that's for the high heat settings, because some dryers have like a high heat and no heat. I mean, not no heat. High heat and low heat, okay? Alright, so now let's go ahead and test these two right here. I think that's for your low heat setting. I have no idea. Probably low or high heat, because my dryer has that temperature select that's built in on the timer dial. Okay. All right. So I'm gonna go ahead and test the thermostat again. We should get a good reading of 0 ohms. All right. Oops. Oh, hang on here. think we found another culprit. Alright. Let me double check. Alright. 0.70. 7 ohms. I don't think if it's good for the cycling thermostat, but do the same thing. We do get some reading, which is good. Alright. 7.78 ohms. Let me go ahead and show you the display real quick. Got the sniffles, man. Alright. Alright, I'm gonna test out the thermostat one more time. The cycling thermostat on the other wires. I think that's for the low heat or something, or either high or low. I have no idea. See, 0.7. Not 0.7. 7.78 ohms. I don't think if it's Alright, 0.78. I don't know if it's good reading or not, but because the meter does not beep, indicating that we don't get any good readings. But alright, so let's go ahead and get the cycling thermostat plugged back in. So now we know we had a, let's see, we had a shorted heating element. Let's see, we got a bad thermal switch right here. We got, we got the cycling thermostat partially tested. And now let's go ahead and test out the bad part, which is the thermal cutoff fuse. Remember that we explained what the thermal cutoff fuse actually is? Now it's a matter of testing it, because you never know when you get a bad thermal fuse, the dryer won't run or heat, or both run. It would not run and heat. Chances are this part right there is gone bad. Alright, so I'm gonna go ahead and move my camera, that way we can see the terminals better. Get this back in focus. Oh, let me do this. There we go. Alright, so I'm gonna go ahead and test. Boom, I think we found the problem. The thermal fuse is blown. Okay? We'll check the other side. Alright. We have no reading. The display on my meter says auto, but depending on what meter you work on, your maybe said OL, meaning open line. So now you know we had a bad thermal cutoff fuse, and it needs to be repaired. If not repairable, replace it. So this fuse will need to be replaced if it's not repairable. I think the thermal cutoff fuse is not repairable. So now you know we got a bad thermal cutoff fuse. All right, guys. So let's see. Go ahead and plug these back in. And I think just about all it for the testing of your dryer that's overheating. So now it's a matter of putting it back together, but don't plug it in just yet. And you can, Alright. So let's make sure we got everything put together before we put this back panel on. Alright, so make sure we got everything put it together. make sure you got a good connection, because sometimes if it doesn't work, for some reason, chances are gotta make sure you check your wiring before we put it back on. That's the part of your reassembly. You gotta make sure you check the wires and such. Alright, the wires are good snug. Let's go ahead and put the back on. And be more careful. Like I said, it's very sharp. Actually, go ahead and turn off the meters so you don't drain the battery. Okay? And let's go ahead and put the back on. So the cord, get this cord right there. Oops. It's kind of hard to do it. I know. I told you guys it's hard to do it while you're filming. So we go ahead and there we go. And that, all right. And you gotta make sure you line up with the screw holes. And alright, I think we got it. Doesn't have to look that perfect, but just take your time and do your best. Alright, so let's go ahead and put the screws back in. I'm not gonna plug it in just yet, but now we find the problem. It was the bad, let's see, shorted out heating element and the bad thermal cutoff. I mean, not the bad, yeah, bad thermal cutoff fuse and thermal fuse. All right, so now, all right, and that concludes our dryer troubleshooting. Now it's a matter of fixing it, getting your parts replaced, and now it's a matter of parts replacement. I'll make a video sometime to show you how you can replace the heating element, the one that shorted out, and just put the new one in. Alright, that screws in. I'm not going to plug the dryer in just yet, it's because it's still not working, and we need to be more careful with the, oops. Screws are magnetic. Just make sure you get as tight, screws nice and tight as you can. You don't want to make it too tight, okay? In case when something happens in your dryer ever again, then that we got, It doesn't have to look that perfect, and I'm talking about your screw alignment. Yeah, it's safer when you keep it unplugged, because we need to help protect the dryer from further damage until you get it going for good. So, all right, go ahead and put the screws back in. I don't know if y'all can see it or not, but it's a little loud, but just don't panic.
Still working on that thing?
Yep, I'm just...
Oh, I need to go pee.
Alright, I mean... Alright, let me go ahead and continue to put the screws back in. Oh, hang on, Alright. Alright. Once you get all the screws put back in, go ahead and put the vent hose back in. First, we have to unscrew that little screw. This is how you make your tightness of your vent. You want to make it more or less tight if you want. Okay, let me get my I have to turn this back on. Alright. Go ahead and put the vent back in. Also, you gotta make sure that we do a visual inspection. There's some lint right there. Right. Go ahead and reset my camera. Put the vent back in. Oops. Here. I don't know. I mean, get the camera to a different angle. Ooh, smells good in here, Daddy. What you making, my love?
Oh, making my dinner.
Making your dim-dim? Alright. What? Oh yeah, yeah. Blaster. Have we got anything from them yet?
Check in the morning.
We were telling you. Thank you.
Mm-hmm.
Alright, so once you got your vent hose hooked back up, go ahead and push your dryer back in, but we'll keep it unplugged just to be more safe. So check the prongs on it too. Alright. Push the dryer back in, but don't plug it in yet, because it's because it's not working and we need to help protect it from further damage.